Hey guys, Zulk here, back on my bullshit. It's been a bit, and before I continue any further into the video, it's time for the mandatory disclaimer. And in case you're wondering, no, I don't pre-record these. I literally just say this off script because I don't have a script, and at the start of every recording session. So, yeah. If you clicked on this video because you need to learn how to do a thing in C++ or you need to learn C++ in general, this is not the video series for you. While I do think that by watching this series you may be able to learn how to do this or that in C++, it's not going to be very effective or fast. So if you're clicking this video for the purpose of learning C++, I recommend you click off and find a better tutorial. I'm sure there's plenty on YouTube. The purpose of these videos, well, this whole series actually, is not to teach someone else C++, but rather to basically document myself as I am trying to learn C++ by myself. I'm not an expert. I'm just some dude who knows a few other programming languages like C and Python, who is trying to teach himself C++ using a book. So yeah, you might learn C++ if you follow this series just by watching me stumble and do shit, but it's not going to be fast or effective. So if you need C++, find a different tutorial video. And whatever you need C++ for, good luck with that. I wish you luck. Hope everything goes well for you. With the disclaimer out of the way, everyone who's left here, let's continue the video. So, the reason I haven't been recording much for the Zulk BS channel is, well, I also haven't been recording much for the Zulk RS channel either, and it was mainly because I kept getting sick. Sometimes it was a full-on fever that hit me for 2 days or something. Other times it was like a cold, like I have a slight cold right now as I'm speaking. Or throat pain. The throat pain is usually what keeps me from recording more than fever or cold. And yeah. But anyway, while my throat does feel a little gummed up, I don't have any pain. So we are good to record. Besides, I really need to finish C++ because I want to make a game already. I am partially thinking of just stopping this series altogether and instead jumping straight into doing shit with Godot. And I wanted to say Unreal, but then I realized my computer is nowhere near powerful enough to run Unreal. So yeah. Anyway, let's get on with it. A closer look at classes. This is chapter 3 of Teach Yourself C++, 3rd edition by Herbert Schlitt. Not gonna read everything line by line. Just gonna read stuff silently and read aloud those parts which I think is important. Huh, interesting. So apparently this chapter will cover how to pass objects to functions and return objects from functions. That sounds like it's going to be really important and really useful. And a new type of function, the friend. I don't know what a friend is. Yeah, quote that out of context. But anyway, let's see. I'm skipping the exercises because I'm semi-speed running through C++ here. And if I spend... We are gonna be here forever if I spend too much time on trying to do all the exercises on camera. Assigning objects. One object can be assigned to another provided that both objects are of the same type. By default, when one object is assigned to another, a bitwise copy of all the data members is made. For example, when an object called O1 is assigned to another object called O2, the contents of all of O1's data are copied into the equivalent members of O2. They gave an example. Let me read it. Oh, this is an inline function. Oh, oh, oh. I need to show you guys this. Hang on. I'm just gonna copy this from the book word for word just to show you the insanity that this thing is. Mind blown. Mind blown, guys. Class, my class. I am not even bothering to make up my own shitty names. I'm just doing this as it is in the book. Two integers, yes. Then public void set int I and int j, and then we have a equals to I and b equals to j. So basically this is setting the value of a and b, this function, and then we have another void show. This is not how it was written in the book, but I like writing the void there in the function. It helps me keep track of shit. And show does see out a space then b then backslash n. Okay, and then we have int main void so over here we declare two objects which belong to the class my class. Then we do this o1 dot set. I'm actually going to change up the code just a little bit. I know I showed you shit, but I want to show you this like this. O2 set something completely different. 3 and 9. Yeah. Now O1 show, O2 show. So first I'm going to run this code. Save, build and run. What? Hold on. What did I just do? Why did... One sec. No, I don't want to save it. My mouse... Wrong thing. My mouse is not working well, guys. So... Yeah. Okay, go back to this. perspectives, default. Yes, go back to default. Why is this not working? Did something break? Okay, this works. This works. So that means I must have made a mistake somewhere over here. Which is this the problem? No. Oh, I see what the problem was. I see. I am an idiot. I accidentally included main as part of the class, and here I thought it was some kind of compiler issue. See, this is the kind of bullshit you will never see. This is the kind of bullshit you will never see an experienced programmer make in one of those tutorial videos. And now I forgot to do this. Okay, this time everything should work. So as you can see here, yeah, after I made some stupid mistakes, but as you can see here, I have the two objects of my class O1 and O2, and I set their values 10 and 4, 3 and 9, and I'm showing both. Now watch what happens when I do this. O2 equals to O1, and now O1 show, O2 dot show. Ta-da! The exact data that O1 had in all of its internal variables and potentially some of its functions as well. I don't know, maybe just the variables. I'm not entirely sure yet. It could turn into an exact duplicate of O2 at this point in time. Like I could probably, hey, like after this line, I could probably change O2's data again. Sorry, O1's data again, and they would be different again. O2 would then have the same data that O1 had at the time of this thing. So essentially, I am basically doing this, but on a function scale. I mean, on an object scale. That is so cool. Yeah, I didn't know C++ could do this, and again, this was a mind-blown experience. Awesome. Okay, so the next part is just explaining what the hell happened. Keep in mind that an assignment between two objects simply makes the data in these objects identical. Two objects are still completely separate. For example, after assignment, calling O1.set to set the value of O1 has no effect on O2 or its A value. Yeah, I just said that right now. That is cool. That is actually cool. Now this part, passing objects to functions. Objects can be passed to I messed up reading that, and I don't know why. I felt like I tripped over my own tongue. So let's try that again. Objects can be passed to functions as arguments in just the same way that other types of data are passed. Simply declare the function's parameter as a class type, and then use an object of that class as an argument when calling the function. As with other types of data, By default, all objects are passed by value to a function. Let's see the example. Oh, so basically what is saying, I'm not going to write a functioning code here. I am just going to show you what we just read means by typing some random bullshit over there, just as an example. So here we have a class, my class, right? If I were to this, I am sorry for the snorting noises. Like I said, I'm still a bit sick, and I do that trying to clear my throat. I am very sorry if that bothers you. But anyway, so we declared a class, my class, right? And and again, over here we set O1 and O2 as objects of my class type, right? We can do write functions. Like, let me explain. Let's say this is a function, func, and normally it can be void, but we can, if we were to write a function that takes, say, two integers as arguments, we write it like this, right? Like, see over here, we did it. But apparently, we can do something like this as well, where instead of taking integer a as an argument, it can take my class as an argument, a, which is an object of my class data type, which is this class. We can have a function that passes, that is given an object as its argument instead of something simple like an integer or a string or a floating point number or just void. I feel like this is going to be really useful. Another thing that's going to be really useful. So what's next? Hold on. This slide might be important. The default method of parameter passing in C++, including objects, is by value. That means that a bitwise copy of the argument is made, and it is this copy that is used by the function. Therefore, changes to the object inside the function do not affect the calling object. Oh, okay. So basically what this says is, remember the example I did right here? Now, if I if I made this an actual function and included it here, like let's say func and o1, anything this thing outputs is not going to affect the actual values of o1 here. When I do this, it's not passing o1 itself, it's passing all the values inside o1, a copy of it, much like this thing. So yeah, that's what that meant. And of course, we can just pass an address as well to modify the actual class that we're passing into it. What's this? When a copy of an oh, I remember, I just realized something. I read through like a bunch of lines and I forgot to read that to you, even though I thought it was important. As with other types of variables, the address of an object can be passed to a function so that the argument used in the call can be modified by the function. Basically, what it's saying is that when doing this, instead of my class A, if I send the address of, I think you send the address by doing this. If I do this, then it will indeed modify. Sorry, I made a mistake. So yeah, instead of doing it like this, if I do this, it will indeed modify the value of O1. Right? That's what it says, right? Oh, I used the wrong thing. It should be like this, I think. So yeah, uh, if I do it like this, O1 is actually going to get changed by the function. And let's see what this says. When a copy of an object is made when being passed to a function, it means that a new object comes into existence. Also, when the function that the object was passed to terminates, the copy of the argument is destroyed. This raises two questions. First, is the object's constructor called when the copy is made? Second, is the object's destructor called when a copy is destroyed? The answer may at first seem surprising. When a copy of an object is made to be used in a function call, the construction function is not called. Yeah, I figured it's not. The reason for this is simple. To understand if you think about it, is simple to understand if you think about it. Since a constructor function is generally used to initialize some aspect of an object, it must not be called when making a copy of an already existing object passed to a function. Doing so would alter the contents of the object. When passing an object to a function, you want the current state of the object, not the initial state. Yeah. However, when the function terminates and the copy is destroyed, the destructor function is called. This is because the object might perform some operation that must be undone when it goes out of scope. For example, the copy may allocate memory that must be released. To summarize, when a copy of an object is created because it is used as an argument to a function, the constructor function is not called. However, when the copy is destroyed, usually by going out of scope when the function returns, the destructor function is called. Okay, I'm going to read this example not aloud but by myself because I think that whole shit that I just read is self-explanatory. I don't think that requires any further explanation. At least not from an idiot like me who, again, is no expert when it comes to this shit. The fact that the destructor for the object that is the copy of the argument is executed. Wait, the fact that the destructor for the object that is the copy of the argument is executed when the function terminates can be a source of problems. For example, if the object used as the argument allocates dynamic memory and frees that memory when destroyed, its copy will free the same memory when its destructor is called. This will leave the original object damaged and effectively useless. It is important to guard against this type of error to make sure that the destructor function of the I choked on my own spit there. It is important to guard against this type of error and to make sure that the destructor function of the copy of an object used in an argument does not cause side effects that alter the original argument. As you might guess, one way around the problem of a parameter's destructor function destroying data needed by the calling argument, as you might guess, one way around the problem of a parameter's destructor function, destroying data needed by the calling argument is to pass the address of the object and not the object itself. When an address is passed, no new object is created and therefore no destructor is called when the function returns. However, an even better solution exists which you can use after you have learned about a special type of constructor called a copy constructor. A copy constructor lets you define precisely how copies of objects are made. That is discussed in a later chapter. Okay, that was enlightening, I must say. I am gonna take a drink right now. I'm gonna drink some water. Also, I'm gonna check if I have actually been recording this whole time, which I have been. Nice. No, I am not pausing because even in my main channel videos, when I go to pour myself a glass of water, I usually don't pause the recording. So you know that. Alright, where were we? The new topic, returning objects from functions. Interesting. When an object is returned by a function, a temporary object is automatically created which holds the return value. It is this object that is actually returned by the function. After the value has been returned, this object is destroyed. The destruction of this temporary object might cause unexpected side effects in some situations. Also, in case you're wondering how you can write a function which returns an object, again using this as an example, writing a bullshit problem riddled line here which won't run ever, but just giving you an example of how things work. When I write a function like this, it basically means that this function will return an integer value. So following the same logic, if I write a function like this, it means it will return a my class value. Make sense? Yeah. I'm gonna read the examples by myself now. You must be careful about returning objects from functions if those objects contain destructor functions, because the returned object goes out of scope as soon as the value is returned to the calling routine. For example, if the object returned by the function as a destructor function that frees dynamically allocated memory, that memory will be freed even though the object that is assigned the returned value is still using it. The key point to be understood from this example is that when an object is returned from a function, the temporary object used to effect the return will have its destructor function called. Thus, you should avoid returning objects in which this situation is harmful. Again, directing me to chapter 5. And now it's time for the part I've been waiting for. Completely new ground. And apparently this is the last topic of chapter 3. Yeah, I think it's a good place to end the episode after I do the last part of chapter 3, because that would mean that I completed a chapter. How? I need to check something real quick. Um, wow. So chapter 3 is actually really small as far as chapters go. 4 is big, 5 is medium. Okay. So yeah, let's just ignore that for now and do the final part of chapter 3. Completely new ground for me. An introduction to friend functions. There will be times when you want a function to have access to the private members of a class without that function actually being a member of that class. There will be times when you want a function to have access to the private members of a class without that function actually being a member of that class. Yeah, okay. Towards this end, C++ supports friend functions. A friend is not a member of a class, but still has access to its private elements. Two reasons that friend functions are useful have to do with operator overloading and the creation of certain types of I/O functions. I/O means input-output in this case. You'll have to wait until later to see these uses of a friend in action. However, a third reason for friend functions is that there will be times when you want one function to have access to private members of 2 or more different classes. It is this use that is examined here. Okay. A friend function is defined as a regular non-member function. However, in my head, where I read defined, I was thinking the physics kinds of defined and not the programming kind of defined. I need to read that line again. A friend function is defined as a regular non-member function. Okay. However, inside the class declaration for which it will be a friend, its prototype is also included. prefaced by the keyword friend. There's an example here. I see. So again, I'm going to write some bullshit code that does not actually work just to explain what it is I just read. So basically, let's say this is my class. It has some private elements. Let's say, yeah, this is my class, private, and int A and int B are the private elements. This program still runs, right? Yeah, private elements. Okay, now question, I need to check the example one more time to see if, yeah, right here. So, and in the public section over here, we have this function, right? Void set. Now let's say I want a function called friend. I want a function named this to be a friend function of my class. So I write something like this: friend int friend void. If I do this, what this does is basically say that the friend function here, oh, and I need to do this. What it says here is that the friend function here is, well, the friend function of my class. I should have named it something else. Let's try that again with less confusion this time. When I write something like this, what this is saying to the code is, hey, my class is a class I'm defining. It has the private elements, these things. And there is a function that is not part of my class, like show is a part of my class, but there is a different function called fun, which is not a part of my class, but that function, in spite of not being a part of my class, should have access to these things as if it were. This is what this thing is saying. And then outside over here, I like define the function fun as if I was defining a normal function. That is essentially what that meant. How friend functions work. That is essentially how friend functions work. So yeah, simple enough, really useful though. And by the way, remember that thing I just wrote and I accidentally deleted because I don't make my videos scripted at all. So I suddenly realized, hey, maybe I shouldn't have deleted that before I finished talking about it. But whatever. You know that thing I just wrote, friend int fun? Yeah, I can write that in more than one class. And then the fun function will have access to the private elements of all sorts of different classes. Neat. I'm already thinking of ways this might be useful when trying to develop a game. Let's continue reading. Oh, here it is. It is not possible to call a friend function by using an object name and a class member access operator. Yeah, basically you can't do shit like this with friend functions. Let's read this note because it seems to be important. The preceding paragraph brings up an important side issue. When a member function refers to a private element, it does so directly because the member function is executed only in conjunction with an object of that class. Thus, when a member function refers to a private element, the compiler knows which object that private element belongs to by the object that is linked to the function when that member function is called. However, a friend function is not linked to any object. It simply is granted access to the private elements of a class. Thus, inside the friend function, it is meaningless to refer to a private member without reference to a specific object. Yeah, I think I got understood what that meant. I think. I'm not sure if I understood what that meant. But I feel like I did. Can explain it to you though. That's for sure. Friend function is not inherited. That is when a base class includes a friend function. That friend function is not a friend of a derived class. Interesting. One other important point about friend functions is that a friend function can be friends with more than one class. Yeah, we know that already. There needs to be some way to tell the compiler about a class name without actually declaring it. This is called a forward declaration. In C++, to tell the compiler that an identifier is the name of a class, use a line like this before the class name is first used. Class name. So class and then class's name. Oh, basically this is a forward declaration. Let's say there was a different class called class B. Let's say there was a different class and my class's friend function needed to use something from class B, but it was impossible to have class B appear after my class. So what we would have to do is do it like this, and then we can use B inside the friend function of my class. I hope I'm explaining that properly. A friend function can be a member of one class. Sorry, a function can be a member of one class and a friend of another. Okay, good to know. Okay, so friend functions. I think I learned that. That was, by the way, the last topic of chapter 3 in the book. And I got really confused by the end of it, especially with this thing called. Hang on, I shouldn't have closed the book so easily. Scope resolution operator. Like there were examples and I read it and I think I have a vague idea of what it is, but I'm still not 100% sure I got it. But it's fine. I did learn what a friend function is, scope resolution or not. And I do think I learned a lot from this chapter. So, how long have I been recording? Almost an hour. That this was a good. In case you're wondering why I did that, it was a combination of me being distracted, trying to talk, and also my mouse being a piece of shit. So, yeah, I recorded for almost an hour and I learned a bunch of new stuff, to be honest, like different functions and passing the functions to objects and returning passing classes to functions and returning classes from functions, shit like that. Overall, I feel kind of tired. I feel like my brain is overheating, but I also feel a bit accomplished and enlightened and like I really increased my intelligence score or some shit. So, I almost hit the stop recording button. So much for increasing intelligence score. So, even though I wasn't able to do it last episode due to internet problems, let's do the traditional chess match to unwind because I sure as hell need it right now. Alright, we are at chess.com and I feel tired. But it's fine. It's fine. Let's hit play. Let's get this started. I'm gonna unwind while playing. Oh. Okay. I got matched with like 1,000. Oh. I got matched with someone 1062 rated. This is gonna be a hard match. I need to lock in. And of course, I'm gonna do the Dudas Gambit because I like it. I call it the Gambit because it ends every time I play it, bullshit happens. I panic, he panics, everyone panics, and then either I win or lose. Anyway, I'm gonna push this pawn to attack this bishop. I think he will move here. Yep, as expected. Now I wanna move this here, but I can't move this here because then I'll get unpasanted. I wanna take this, but I can't take this because if I take this, then the bishop is gonna take me back. If I do this, then this. I'm gonna do this first. Okay. I gambited one pawn, I'm gonna gambit another one. I do not give a shit. In fact, even if you take, you didn't take. Instead you're attacking this one. I'm gonna move this up. If takes, I am gonna attack your queen, forcing you to move somewhere. Okay, let's see. If I attack you here, where can you actually move? You can move here. You can't move there. You can't take. You can move here. And here as well. Moving here is going to be especially bad. I'm gonna take this chance to... Wait a minute. Hold on. This here, you can move here. You can't move here. You can move here. No, you can't. Can't. Yeah, I think I wanna attack you. Now, this is one of the only safe squares you can move. Or that, but I I am actually not worried about that at all. I definitely should be, but I'm not. My mouse malfunctioned. I'm gonna move my knight here to protect my rook like this. Now I'm gonna move this here. I can just take this, right? Take an attack. Am I? Hold on. Take. Check. This check is coming. And if I check there, then I can move my knight back. This, I'm gonna move my knight back. As expected, I could sacrifice my bishop. I'm gonna do this instead. Okay. Okay, I guess. Are you gonna move here trying to pin my knight? You moved there trying to pin my knight. I am just gonna develop again. Oh! No. This does not work. What are you trying to do here exactly? I'm just gonna do this. I don't know what he's trying to do, guys. Oh. Oh, that's what you were trying to do. And he wants a rematch. Sure, why not? Let's do a rematch. Besides, I didn't do a what was I saying? Oh yeah, I didn't do a chess match last episode, so doing two this episode against the same opponent is good enough, I guess. I'm now gonna move this here. What are you gonna do? I'm assuming this is coming. It didn't come. But now I can't move my pawns up further. I don't want to move my pawns up further, question mark. Damn it, I was still thinking about it, but unfortunately, my mouse is not in the best shape. I'm gonna move this here. If takes, then this. And I'll be fine. You can't take here. Perfect. Oh. I see what you're doing. I see you. I'm still gonna do this. I know this is coming. I know it. Isn't that a straight blunder of a queen? What? Take. Then what? What's the play? You can't do this because I'm just gonna take. I'm I'm taking. Again, you can. What? I'm gonna. Oh. Were you trying to get me to trap my own queen? I'm gonna defend with the bishop. I guess I could have done this. And now it looks like a good time for me to get my queen the hell out of there. But the question is, where do I move? Do I move all the way back undeveloping myself? Or should I move somewhere else? Okay, let me think. I can move here and then you move like this, but then I take en passant and then you take with your queen and then this is under attack, I guess. If I fuck it, yeah, let's move it here. Either this or this is coming. Either way, the fuck. Oh, okay. Are you trying to... Are you trying to target this so that... Yeah, you're trying to fork me here. Fuck it. Queen back. I am now guarding this thing. I could have castled right here. But I have a feeling if I did, I would open myself up to that side attack. I don't know what the point of that is. I'm a move my knight. I could do this. I need to move my bishop out of there somehow. Oh! I just noticed a way to get his knight off my back. Move here, check. Then you have to move this way because if you block with something else, you have to move this way now. No, you just blundered your knight, I think. Because now no matter what, I'm just gonna straight up win this knight. If you move here, that's especially devastating because you're gonna walk into a check. If you do this, I'm taking. If you do this, it's especially bad because I'm taking. Like this. And then I'm gonna go back. Wait. Hold on. Hold on. Knight back. I take. You move here. My queen is trapped. Not right now, don't worry. I'm not trapped yet. But I would have been if I took a knight. Yeah, I'll do this instead. Attacking my queen again, are we? No shot. Can I even get out of here? Am I just straight up trapped? Fuck it. I think my queen is trapped, guys. I need to find some place. I'm gonna do this. I'm gonna try and save my queen. It's probably a bad move. I probably should have just offered a queen trade right then and there. Offered this way. So I still had this. There it is. There it fucking is. I can move here still. Hold on. Takes. Yeah, this is a queen trap. If I take, then that's awful. If I do this, then takes, then takes, then takes. I have no choice. Offer a queen trade right now. I am not even just offering. This is a forced queen trade. Because you can't, the queen can't move. This queen, it can't move from there. Maybe I can do shit like this. Like, if I'm just saying, if you just leave this situation as is, what can I do? Probably this to deflect the pawn this way, so I can go back and unfuck my queen. But then the rook will come down here. This. That's protected then. Oh, okay. I mean, if I move this, let's say takes, I take here, rook down, I move down to protect myself. So I'm going for it. Do this. Oh. Hang on. Let's say I do this. And then you come here, pin my knight to my king. No, that's not gonna work. I take this. You take me. No. I'm just gonna take this. I think I'm better. Do you not see my bishop? You're acting like you don't see my bishop. This white bishop. You're acting like you're not seeing it. And with that, you closed the queen trade completely. You know what? It's fine. Because I didn't want to trade queens anyway. I was trying so hard to save my queen. So that actually works out well for me. Boo. I still have escape options. Do I? Do I still have escape options? I do. I feel like I have escape options. I'm gonna have to move my bishop out just so I can castle. I can move my knight. I can push this pawn, I guess. This is a passed pawn, isn't it? Also, I can create a battery, but that's kind of pointless right now. Oh, you're connecting the rooks. My queen is not safe. She is 100% absolutely not safe. I can't move this knight anywhere. If you don't know what else to do, develop. I'm gonna move my bishop. And I'm going to do this. I'm gonna castle. Oh. You are definitely trying to attack my queen. I do not appreciate you doing that. So, tell you what. I am gonna find a way to get out of here. I know you're gonna move here, I think. And I am gonna move here to protect this. And if this, then I just straight up take. Actually, if you move there, I am... Yeah. I think I know what your plan is. I need to move my queen. Then you're gonna come here, do this, pin my knight. Yep. You're gonna do that. But this is actually 100% fine. I can just move my bishop back and protect you that way, and I blundered my own bishop. I really need to castle. Please don't see this. I should have thought about that move more. I made a blunder. I messed up. I probably could have moved my queen up instead, guarding both this and this. That would have been the good move. Ay. Oh, this is extra special, super duper devastating, because that'll block off my castling. Fuck. I probably should have castled it sooner, but I didn't get the chance. Why is he thinking for so long? Just take? If you don't take this, I'm just gonna do this as a desperado move. How long has he been? How long have we been on this screen? Okay, let's just assume he does this. What's my game? Wait, Stockfish says I'm better? What? Oh, 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 oh. This, I never blundered this because this pawn was protecting it the whole time. Amazing. I don't know why he suddenly abandoned it though. And I don't know why Stockfish thinks I'm plus 10.3. Stockfish thinks that I'm absolutely killing it. But I'm not. Wait. When did you lose 2 knights? The fuck? Hang on. Go back. Go back. How am I plus 8? Okay, so I took 1 knight there. Then I took the second knight here. Then I took that pawn and then I took this pawn. Stockfish says that I was like at a clear advantage this whole time. But I felt like I was on the back foot this whole time. What is happening? Oh, this last move did not actually happen because yes. I have no idea what the fuck just happened. But a win is a win. I'll take it. And with that, I think I'm ready to end the video. I need to do a bunch of editing. So guys, that's it for this video. If you like this video, be sure to leave a like, comment, and or subscribe. Dislike it if you hated it. I'll heart your comment to let you know I've read them. So just because I added your comment doesn't mean I agree with it or endorse it. I'm Zulk RS and I'll see you next time with more bullshit.